In April 2026, Tesla opened orders for the Semi. By the next morning, 50% were gone. Each truck cost $300,000. The buyers were not enthusiasts, they were freight companies, and what they found when they actually drove it is the part nobody is talking about. Large fleet operators are no longer waiting. They are fighting to secure units from a production line that cannot build fast enough. Before we continue, subscribe to the channel so you do not miss future updates. Tesla officially began mass production at Gigafactory, Nevada on April 29th, 2026. The target is thousands of units by the end of this year. Eventually, 50,000 per year. But here's the problem: Tesla did not expect to have this early. Demand is outrunning the factory. WattEv dropped $100 million on 370 semis in a single purchase commitment made in early May. California's zero emission truck incentive program logged purchase commitments from 89 separate fleets totaling 1,095 vehicles, all in the first quarter alone. These are not reservations. These are not letters of intent. These are funded purchase commitments from commercial operators who evaluated the vehicle, ran the numbers, and decided that last detail matters. Fleet operators do not spend $100 million on a hunch. They run route analysis, total cost of ownership projections, maintenance forecasts, and driver feedback loops before a dollar moves. The fact that WattEv placed that order and that 89 independent fleets followed tells you something the spec sheet cannot. The product is convincing people who are paid to be skeptical. When 89 independent fleets reach the same conclusion at the same time, the product is doing the convincing. But none of that explains why. To understand why, you have to start with what is actually inside this truck. The standard Semi carries 548 kilowatt hours of usable battery capacity. The long-range version carries 822. For context, a Tesla Model 3 runs on 64 kilowatt hours. The long-range Semi carries nearly 13 times that amount of energy in a single vehicle. That 822 kilowatt hour pack delivers a 500-mile range under real loaded conditions. Not test track conditions, not ideal temperature, empty trailer, flat highway conditions, real freight, real routes, real weight. 500 miles covers the full working day for the majority of Class 8 routes in the United States. One charge, no stops. And when it does need charging, 60% of range recovered in 30 minutes. That window lines up exactly with the federally mandated rest break that every commercial driver is legally required to take. A driver hits the 30-minute break requirement, the truck recovers 300 miles of range. The downtime was already built into the schedule. Now it has a second job. That is the battery story. But the battery is not what convinced the drivers. What convinced the drivers happened on a mountain. Covenant Logistics runs more than 2,600 tractors across North America. They are not a startup. They are not an advocacy group. They are not trying to make a statement about clean energy. They are a serious commercial freight carrier. And they spent 2 weeks running a fully loaded Tesla Semi through the Grapevine, the section of Interstate 5 that connects Southern California to the San Joaquin Valley. The Grapevine is not a test track. It is one of the most demanding freight corridors in the country. Tejon Pass hits 4,160 feet of elevation. It is a primary artery for cargo, moving out of the ports of Los Angeles and Long Beach into distribution centers across the state. Millions of tons of freight travel this route every year. The challenge is the grade. Northbound trucks climb steep inclines under full load, tens of thousands of pounds of cargo. Any loss of momentum on that grade becomes a compounding problem. Regaining speed while pulling a heavy load uphill demands enormous sustained power output. Drop below a certain speed threshold and the situation becomes very difficult very fast. Diesel trucks struggle here, even modern, well-maintained ones. Drivers manage gear selection constantly, watch RPMs, work to hold speed. It is a physical negotiation between the driver, the truck, and the grade. The moment the engine cannot deliver what the hill demands, the driver feels it immediately. The Semi does not negotiate. Its tri-motor electric powertrain delivers full torque from 0 RPM. There's no turbocharger spooling up the pressure. There's no torque curve that peaks at a specific engine speed and falls off on either side. No gear selection, no waiting. The moment the grade steepens and the load gets heavy, the power is already there. All of it. Instantly, drivers reported that the Semi simply held momentum through sections where a comparable diesel would have started losing ground. That is the climb. Now here's where the story gets more interesting. The southbound descent from Tejon Pass drops 2,613 feet over 11.6 miles. The steepest section holds a 6% grade for 5 continuous miles. Most people outside the trucking industry assume the hard part of a mountain route is going up. Professional drivers know the descent is where things can go wrong in ways that have serious consequences. At 80,000 pounds gross combined weight, a truck descending that grade is building kinetic energy continuously. Gravity does not stop. The truck has to manage that energy every second of the descent. In a diesel truck, the primary tool is friction brakes. Friction brakes convert kinetic energy into heat. Long descent, heavy load, steep grade, the heat builds. If it builds faster than it dissipates, braking performance starts to drop. That is called brake fade. It has caused serious accidents in mountain trucking operations for decades. Every experienced driver knows the feeling. The pedal gets soft, response time increases, and the situation can deteriorate quickly. Managing a long descent in a diesel requires constant attention. Correct gear selection. Engine braking balanced against surface brakes. Speed discipline maintained throughout. Mistakes have consequences. The Semi changes the equation entirely. On a descent, the electric motors reverse their function. Instead of consuming energy to turn the wheels turn the motors. The motors become generators. That process produces electricity, which flows back into the battery pack. The resistance generated by this process is what slows the truck. Gravity, instead of being a force that must be managed through heat dissipation, becomes a charging input. Friction brakes barely activate, brake temperatures stay low, the risk of fade drops to near zero. The driver controls vehicle speed through a system that is simultaneously slowing the truck and recovering energy cleanly, consistently, without generating the thermal stress that makes long mountain descents so demanding in a diesel. Matt McClellan, Covenant's Vice President of Sustainability and Innovation, reported what the driver said after 2 weeks on that route. The driver said he felt more confident in the Semi than in a diesel. That driver hauls freight for a living. His safety and his livelihood depend on the truck doing exactly what it is supposed to do when the grade gets steep and the load is heavy. He was not responding to a press release. He was not on a closed course. He was doing his job on one of the hardest routes in the country for 2 weeks straight. And at the end of it, he said he would rather be in the Semi. That statement carries more weight than any specification Tesla has ever published. The numbers across the industry. Covenant is not the only company running these evaluations. ArcBest accumulated 4,494 miles in 3 weeks of structured testing and recorded average energy consumption of 1.55 kilowatt hours per mile during normal freight operations. Dell Supply Chain completed a 3,000 mile evaluation hauling full commercial loads and measured 1.72 kilowatt hours per mile before placing its first order. CEVA Logistics reported measurable reductions in operational emissions across its testing period. NDB Transportation and ALO Logistics both launched dedicated pilot programs focused on port drayage, the short haul, high cycle routes that connect port terminals to warehouses and distribution centers nearby. 5 companies, different routes, different cargo profiles, different regions, different operational priorities, same conclusion. The energy consumption figures are clustering in a consistent band. The driver feedback from multiple operators is converging on the same observations. The maintenance data is aligning with the theoretical advantages of electric drivetrains. Independent operators running independent evaluations under independent conditions are arriving at the same result. A single successful test can be a coincidence. A single fleet's positive feedback can be attributed to favorable conditions or motivated reasoning. When 5 separate companies, each running their own program on their own routes, produce consistent outcomes, the result is not circumstantial. The performance is repeatable. That is the most important word in commercial trucking. Repeatable, because a fleet operator does not buy one truck. They buy hundreds, then thousands. Before they scale a purchase of that size, they need to know the first truck performed the same as the 5th, the same as the 50th. The data building across these evaluations is answering that question in real time. That answer is why the order book looks the way it does. Here is where most people assume the story falls apart. The standard Semi costs $260,000. The long-range version is $300,000. A new diesel Class 8 tractor averages $172,500. The Tesla Semi is 50 to 70% more expensive at the point of purchase. That gap is real and it is not small. But look at it from the other direction. The average price of a competing battery electric Class 8 truck currently sits at $411,000. Against that number, the Semi is cheap, more than $100,000 cheaper than its closest electric rival. In a market where fleet operators are comparing electric options, Tesla's pricing is not a liability, it is an advantage. In California, the math shifts further. The state offers up to $120,000 in purchasing incentives for qualifying zero-emission commercial vehicles. A fleet operator buying a $260,000 standard range Semi with a full incentive applied pays a net price of $140,000. Less than the cost of a new diesel tractor in the state that runs more Class 8 freight than almost anywhere else in the country. Then add what disappears from the maintenance budget. No engine oil, no diesel particulate filter, no exhaust after-treatment system, no coolant flushes. Brake wear is dramatically reduced because regenerative braking handles most of the deceleration load. Friction brakes become a backup system rather than the primary tool. Electricity costs per mile run lower than diesel in most markets, and the gap widens as fuel prices move. Those savings do not appear on the sticker. They accumulate across hundreds of thousands of miles over the working life of the truck. Fleet operators understand this math better than anyone. They manage cost per mile figures across entire fleets every month for years. When the total cost of ownership calculation starts favoring the Semi over a diesel across a realistic operating period, the purchase price objection loses its force. The higher number on the sticker becomes a financing question, not a value question. The higher purchase price erodes. The question is not whether the economics work. The question is how long it takes for the rest of the industry to internalize that they do. Tesla has one problem right now. It is not demand. It is not the product. It is not the driver acceptance story. It is manufacturing. Scaling from initial production to tens of thousands of units per year is a fundamentally different challenge than building a compelling vehicle. It requires consistent quality at volume, a service and parts network that can support a growing installed base across the country, a megacharger network that expands quickly enough to serve fleets running long-haul corridors where charging infrastructure does not yet exist, and depot charging solutions that can replenish dozens of trucks overnight at fleet terminals. None of that is fully built. Tesla is building it now in parallel with ramping production. How fast each piece comes together will determine how quickly adoption scales beyond the early committed buyers. The competitive window also will not stay open indefinitely. Daimler and Volvo both have battery electric Class 8 programs in active development. Each brings decades of commercial trucking relationships and established service networks. Tesla's current advantages on vehicle price, on range, on charging speed, on driver acceptance are real. Whether they remain advantages in 3 years depends on execution on both sides. But today, the trucks are selling out in 24 hours at $300,000 each. Freight companies are committing $100 million in single orders. Professional drivers are completing 2-week evaluations on the hardest routes in the country and saying they would rather be in the Semi than the diesel. The direction of travel is not difficult to read. The diesel engine transformed commercial freight in the middle of the last century. It took decades to become dominant because infrastructure, economics, and industry habits all had to shift together. The Semi is not going to replace diesel in a year, but the evaluations that are happening right now across 5 major operators on real freight routes, under real conditions, those are the early data points of something that moves in one direction. If you found this useful, like the video and share your thoughts in the comments. Subscribe for more on the technologies reshaping how the world moves freight.